Hi, this video is going to work through problem 11 from the review exercises. This problem tells us that Sophie owns 5 stocks. We're going to let X be the number of her stocks that have a gain over the next 7 days. So we want to know the outcome space for X. So since she's got 5 stocks, it's possible that none of them might have a gain. It's possible that all of them might have a gain. So our outcome space in A is 0, 1, 2, 3, 4, and 5. Those are the number of stocks that could have a gain out of the 5. Now we're going to consider these events. A is 3, 4, 5. So 3, 4, or 5 of her stocks have a gain. B is the event that 1 or 2 of the stocks have a gain. C is the event that 0, 1, or 2 stocks have a gain. D is the event that 0, 1, 2, 3, 4, or 5 stocks have a gain. So remember, this is our outcome space. We want to know which pairs of events are exhaustive. So let's just review what it means for things to be exhaustive. Exhaustive means that the union includes the entire outcome space. That at least one of the events must happen. So when I sort of look at pairs of events that are exhaustive, right? Say, well, A and B, if those two happened, I still am missing the possibility that there are no stocks that have a gain. So A and B are not exhaustive. A and C are exhaustive because that includes all of the possibility. So A and C are exhaustive. B and C are not exhaustive, right? And since D itself covers the entire outcome space, D is exhaustive in and of itself, right? Which means that A and D, B and D, and C and D must also be exhaustive. So looking at sort of all the pairs of exhaustive events, those are all the pairs that are exhaustive. Let's see. C asks which events are mutually exclusive. Mutually exclusive, remember, means that there's no intersection. So right away we can see D intersects with all of the other events, so that's not going to be in any of our mutually exclusive pairs. B and C obviously have 2 outcomes, 1 and 2, in common, so they're not mutually exclusive. But A is mutually exclusive with both B and C because none of the outcomes in A occur in B or C. So A and B and A and C are both mutually exclusive. Part D asks which of the events are independent. Remember that in order to be independent, the probability of X and Y must be equal to the probability of X times the probability of Y. One thing to note is the probability of D is equal to 1. So technically speaking, the probability of D and A is the probability of A, which is 1 times the probability of A, which is the probability of D times the probability of A. So D is independent of A. The probability of D intersect B is the probability of B. Probability of B. So again, B and D are independent. Probability of D and C is the probability of C. So it's the probability of D times the probability of C. So D A and D, B and D, C and D, those are all independent. None of the other events are independent, because if we look at, say, A and B, if we know that A occurred, there is no intersection of A and B, and so the probability of the intersection is 0, but the probability of each of these events is not 0, so that can't be independent. Same would be true with A and C. And then the probability of B and C, well, if B occurs, then we know C must also have occurred, and so those are not independent either. So those are the only independent pairs. And that's the end of problem 11.